So I've got the Atari SC1224 monitor back on the bench, and one of the things I wanted to address here after thinking about it is I want to replace this 7812 voltage regulator while I have it here on the bench. I just don't see a reason not to. Because I just don't see a reason not to replace it since I've got it here. So I've got him loose. Let's go ahead and unsolder him, and he is these three leads right here. And of course, if you've watched me for more than 30 seconds in a video, you know I've got to put the right glasses on to be able to see what the heck I'm doing. Add a little fresh solder to all three of these. Make it easier to flow them, to desolder them. It's one of those tips, sometimes adding a little fresh solder so that it'll flow easily makes desoldering easier. I'm not even going to bother to test this guy. I'm just going to replace him. He's as old as the monitor. Well, two of the three leads released just fine. Of course, the center lead is the, I believe, the ground. It goes to, I believe, the center tab. And it's going to be stubborn. Of course, it's going to be stubborn. Nope, it did come loose. So it is a 7812 CT. We have just a standard 12 volt regulator. Date code is 45th week of 1986. So it's been in there a while. We'll set this aside and pull out a voltage regulator. 7812s are up here. I've got some really old school 7812s here that I will not be using for this. I'll be using a much more modern new. Got some reclaims here in the box. There's an LM340K-12. I know I have some nice brand new 7812 CT. That should be direct drop in. A couple of pools in here as well. In this case, I want new old stock. 7812 CT, that's actually the same part, but one of these will work just fine. I need a little heat sink grease. I didn't actually look to see on the one I pulled out if it had an isolation pad on it. I don't believe it did. Of course, I'm looking right now around for the one I just pulled out because I have no clue where I set it down at. Oh, I keep forgetting to not put voltage regulators back in the storage bin. There he is. No, there's no silicon pad or anything on the back side of that. No surprise. Just dead heatsink compound. On this side of this one, let me find a little screwdriver that I can use to just clean some of that off out of there with. It's not much of a heat sink, so this hasn't been seeing large amounts of heat. And of course, I never seem to have a paper towel where I need one. Let me wipe this out of here. Just clean it up a bit. And as always, not paying enough attention to where I laid the screw down. There's the screw. We'll get a little dab of this on the back. And of course there's 5 times more coming out of the tube than I need. I don't know how many years I've had this tube of heatsink grease. I know it's been a lot. Use so very little of it. Get the leads to drop down in the hole, which they did just fine. Hopefully I'm getting this on camera. And I'm going to go ahead and screw him in place before I solder him in, and that will keep me from soldering him in a slightly different location orientation. There we go. And creating mechanical strain. I think that heatsink is more, and it's supposedly soldered into the board, and it kind of is. That one flowed well. It's taking a bit of time. And this, of course, will be the one that'll take the most time. The heat sink is, of course, drawing heat away from it. In this case, I do want to trim these little leads. I don't want these shorting down into the metal chassis underneath. Something else I'm going to do while I'm thinking about it, after I put the heatsink compound away, is just take a look over the board. I re-watched the video that I shot last weekend, and I had commented on there being a potential cold solder joint on here. I think it's just a good idea to go over it and touch up anything that looks suspect. I mean, none of them are great. There's a lot of very gray, cold looking solder joints, and part of this is you got to be careful. If it's just got a wire on the other side and you heat it up, the wire might pull loose, and of course that doesn't create lots of fun, as you've got to figure it out and put it back in the right place. But I will touch up the ones that seem excessively horrible. I just had a flake of solder hanging off of it. It's another one that just wasn't a really pretty job. What is the, oh yeah, that's it. Big semiconductor there. Of course, the transformer. Insulation transformer. This PR701, I think, is that soft start component for the power supply. There's an inductor there, and I really don't like the way that solder joint looks. Can I get it to heat? That looks better. It's not a big ball of solder now. It actually is shaped down nice onto the board. Well, I haven't retouched a whole lot of them here. As I'm soldering the caps in, I may spot others. Anyhow, so there is a new 7812. Set this out of the way. We have the caps we pulled out. And we have the box from DigiKey with the replacement caps I ordered. Hopefully, physically, these will all fit. I could have paid a lot more attention to physical dimensions and that kind of stuff when I ordered, but I didn't. So we have replacement caps. For all of these, I ordered double what I believed I needed, as I always do. That's 220 microfarad, 250 volts. Height-wise, it's the same. Lead-wise, it's a little bit different. I may have to do a little bit of trickery with the leads, but that's okay. Faster technology's just gotten better. This is 220 microfarad, 160 volt, which I believe is this guy. And you can see there's a huge difference in physical size. All of these were Nishikon, and they're 105 degree caps. I believe I got 105 degree for all of them. I did. What came out was typically 85, so I've gone with a cap that hopefully will provide a longer service life. I believe we've already replaced this 220 25 volt with something I had in stock. And the rest of these really will just be matching them up one for one and replacing them. So, of course, I've got my notebook stashed away here. I hope that had all our notes in it. So, back to the board. C710 is 220 microfarad, 250 volt, which was this guy. And it's going to be one of these two. $220, 250 volt. The lead spacing is not great. Does sit down in there okay. I've got negative to negative. We'll get some solder on that, and then I'll hold him in flush. This one might take a bit more heat because it's on that large ground plane. Actually, it's a positive, I should call it ground plane. It's a large positive copper pour. So that gets C701 replaced. Where's my pencil? Did I say 701 or was that C710? C710 has been replaced. On to the 220 at 160 volt, which looks like it's C315. We just put this guy in. C315, I believe, is sitting right here. And it is. And again, the lead spacing is a little bit different. Not a huge problem. Hopefully Hopefully I'm getting this all on camera. And then reviewing the video, I did apparently find two highly suspect, one dead and one highly suspect caps, and some others that were questionable. Now we kind of move on to, so we've got a 330 25 volt, 330 25 volt, and a 330 35 volt. I don't remember if I just ordered all 35 volt, which would have been fine. I didn't. I actually got 330 25 and 330 35. That's interesting. So 330 35 volt, there's 1, 2. There's 4 in the bag. Since I ordered doubles, that would make sense. This way I just throw the others into stock. They shared the same shipping fee. So and I've just got extras. I've actually got another power supply and monitor I want to address. So these are 330s at 35 volt. It should be that guy and this guy. Nope, this one. 330 35 volt. So we're replacing these two with these two. They're of course physically much smaller, much newer technology, and these are again 105 degrees C. I'm going to throw the dead ones into the bag of the good ones just so they're out of the way and I know they've been replaced. And the first one of these is C142. It's just a matter now of spotting C142. It's right there. C142 is orientation. I actually haven't cleared out the holes on him. I missed that when we cleaned these up before. C142. Oh, wonderful. Just drop solder flakes all over the board. I hate that. C142. Is this guy. He has the proper lead pitch. So that gets C142 into place. And the other, am I incorrect here? These are 330 35 volt. I've actually just put him in the wrong place. I put him in where a 25 volt cap was meant to live. Not that it would hurt. A 35 volt cap in a 25 volt space. As long as the voltage is larger, it's no big deal. I'm actually looking for C207 and C210. C207, C207, is right here. C207 and C210. C210, yeah, a couple of these weren't marked from the top of the silk screen. So C210 goes in this orientation, negative to negative. So C210. Now I can solder these up. I'm going to come back and reflow this side, because after I soldered the initial lead, when I pulled the solder pencil away, the capacitor actually rocked, potentially compromising that solder joint. If I can spot the other two leads poking out. I don't want to get a cold solder joint because the lead was moving and the solder was solidified. So that's C207 and C210, C207 and C210. I then have the 330 25 volt. There's two of these. Not a big fan of the cut tape. For that reason right there. Of course, they're electrolytics. You need to pay attention to orientation. Longest lead is always positive. The shortest is negative. One of the reasons I just didn't cut him out of there is the length of the leads helps give me confirmation. And I insert the caps, and this is a 330-25, and probably this guy right here, 330-25. Those are going to go in the bag with the 330-25s. And those are at position C143 and C142. I believe one of these I noticed earlier hadn't had the holes cleaned out well. There's C142 right there. So you are going to live right here. If I can get you to go in. And this is one of the ones I chose to replace because it was up near a heat sink. That's 142 and 143. Should not be that guy now. C143. C143 down here. C143. And I have him in backwards. Which is why you double check and then double check again. So C143, negative to negative, he's incorrect. After these are all in, I will do yet one more visual pass just to make sure I haven't got one. And backwards. I can see that that joint isn't as shiny and clean as I would like. Again, check the camera here and make sure I'm getting as much of this in video as I can. That's C143 and C142. We have a 470 microfarad 16 volt. 470 microfarad 16 volt. It's just always amazing to me how much smaller these are. The newer technology, 470 16 volt. Apparently I ordered 4 of these, not sure why. Not that it's bad to have them in stock. So that's a 470 microfarad 16 volt, and it goes in location C407. I don't believe that's that guy. That is C136, and I didn't solder back out the holes for that one earlier. As we'll do it while I'm looking at it. And I keep getting all kinds of solder flaking falling out of the tool. Okay, back looking for C407. So we just cleaned that out. Looking for just open holes. C407 right here. C407. He is not going to get pushed up flush just because there is a pretty substantial difference in lead pitch. Man, not as substantial as I thought. Oops. Takes care of C407. And 33 at 160. 33 microfarad at 160. This guy. I'm sitting here wondering if I didn't order a cap because I seem to be short a bag. So this is 33 microfarad 160 Nishcon 105 degree 33. A little bit of difference in physical size. So C316. This guy maybe? Yeah, C316. So, we should go in this way. That's correct. Yep. That is C316. Did I already replace the 1000 microfarad? Is that one of the two that we got originally? Yeah, it's one of the ones I already had in stock, so that had already been replaced. So, where did I put the dead? Just because I'm going to drop him in the bag, I will sort these dead ones out later and throw them away. So here's the two that we had replaced earlier. So the 220, the 2200 at 25 volt, I had a replacement for, and the 1000, and I decided to hold off. So yep, this is correct. We have the replacement caps have all been soldered in. I'm going to do a quick visual. For polarity, on these, this is one I soldered in the other day. Negative, correct direction. Negative should be down. Negative should be up. Negative should be outside, and it is. Negative should be in there, and it is. Can I already look at this one? That's correct. I've looked at those. So I think we've got those all the correct orientation. I wanted to look at, while I'm here, this guy, which is 2200 16 volt, because I think I'm going to replace him as well, just while I've got it apart. And I believe we have a 220 25 volt that I bought new old stock that we can just substitute in for that, and just while we've got it apart, replace him. You know, full recapping of this would be a pretty big undertaking. There's a lot of small electrolytics everywhere. You know, certainly a bit of time that can be done. His orientation is that way on the bracket with the cap to me. You know, he looks okay. Probably didn't need to do this, but while I've got it apart. And then the replacements I bought, there was a 220 or 2200 microfarad. I thought his value again, 2200 microfarad, 16 volt. 220, 330. Did that 2200? Oh, I actually found that in my stock. I didn't order a new one. Well, I need to go dig through my caps here again and see if I have another one of those. It's huge. Will I have sufficient clearance where he mounts? So he mounts up this way. That's the 470 we didn't use. I'm going to hope there's enough clearance there. Go ahead and swap him out. This is an off-brand 85 degrees C, but it is new old stock. Remove just to get captured here so I don't lose it in case physical size demands I have to put it back in. I'm hoping that'll clear the side of the case when it's put on. It should. The metal bracket this way, the cap was in this corner. Assuming this is still recording, and it is. At this point, it really becomes reversing what we did before and putting this all back together. Give the board one more look over. Now that's more of that black gun. Is that a cap I replaced, or is that one I missed? 330 microfarad. I don't remember that being one I replaced. C214. It's one I missed before. It was just hidden up underneath that heat sink. And I want to replace him while I have this apart. He is a 35 volt 330 microfarad, and I should have one more of those here because I ordered doubles. 330, what did I say, 330 microfarad? 330 microfarad, 35 volt. That's 25 volt. 330, 35 volt. Yep, I have two more. Well, while I'm here, I'm going to go ahead and replace him. I think I just didn't see him up under there before. Let's see if I can get him out of there. It's going to be a little bit tricky given the physical location of him. I don't have a lot of room to move with him. This is another one that looks bulgy underneath to me and wet. That may be another failed one. Clean up the holes. I've forgotten now the location. With this flipped over, location is here. get a new cap out of the bag and not an old one. Okay, come on, little cap. There you are. Again, this should be 330, 35 volt, and it is. $330, 35 volt. Nishikon 105. And orientation is like that. Positive should be there, and it is. Glad I spotted that one. As I mentioned in the first video, I'm working somewhat blind here. I don't have schematics or a service manual. I haven't found it for this monitor. I think I may have found something online. They wanted $5 for it, and I'm a little like, it's only $5, but There's a diode sitting there that I do not remember testing, and based on the huge amounts of black gunk that I see on the one lead, I'm guessing I wasn't able to test it. I'm not sure if that's actually carbon. I think that's carbon. That may be a bad diode. It got missed before. That is carbon. Yeah, no, maybe it's the black gunk. They were holding the cap in place with it. It's so hard to tell. Get in diode test. See if we can get on him. Pretty normal looking forward voltage. I'm going to have to pull that diode out. That diode is very suspect sitting there. D204 must be him. And it is. D204, where'd you go? I spotted him a second ago, and now he's... There he is, D204, completely vanished. We'll just lift one leg out so it's isolated completely from the circuit. Go back and test him again. I released the front leg. Of course, the one what should have released the other leg. It would have been a little easier. Never, of course, have the tool handy that you need to do this with. Oh, excuse me. I was trying not to sneeze there on camera, but wasn't able to reach the stop button quick enough. Oh, where's the little probe? It's always amazing to me that, you know, you use the tool, you lay it down, the tool vanishes. Rinse and repeat. You go round and round, and you know you just used it 2 minutes ago. it's the tool I need to get in there and do this. I don't think I'm going to be able to reach in there with the needle nose and get a hold of that lead. Well, maybe. That looks like that PCB has been very warm. He's in a really difficult place to get in and probe. Like nearly impossible place to get in and probe. Oh, come on. Why do you... Oh, I hate that. It'll make contact just until you need to touch the other lead, and then it slides off. And then it makes contact just till you need to touch the other lead, and then it slides off. Come on. 0.468 forward. Just make sure that it really is open. The other way, and it is. Okay. So that diode actually is fine. The fun part now is going to be getting it back down into a hole. But at the moment I can't see through. It is open. There's just so much black, nasty, whatever they have covered this board with. There's the hole, just covered in nasty stuff. There, he's back down through. It's a lot easier to do this with the board loose than nope, he is not wanting to take solder. Okay, we've got the lead up through the hole this time. Yeah, wire tying this guy off in the first video so I didn't break these wires loose has turned out to be a really good idea. Let me just keep doing a visual. There's a little diode there I probably missed before. And he should be a diode in this direction. Yep, little silicon signal diode. I know we hit all those up before. And then we looked at all those. We checked all these power resistors. That diode was touched before. I think we are getting close to reassembly time. I'm going to stop recording here and take a quick break, and we'll come back to it. Well, I'm moving forward with getting everything back in the case. Let me wipe off the turntable here. Just keep things a little cleaner. So reassembly of this will of course be the adjustment pots here in the back We know that these two screws were used for those ground leads that went up around the base of the CRT. So really this is just now kind of a battle of getting everything back in the proper positions. And the screws back in. And I don't have the photos directly in front of me here, but that's okay. I can work without them for a bit. You know the way this was oriented. The main power inputs here. So that will of course stay the same. There are actually, we'll mount the little board here first. These are those two red leads in the first video where they're both 2-pin, they're both red and white. But I do know how to get those back in correctly. So we'll get this little board set back in place. I have a little container here with all the screws I pulled out. Hopefully I can find the right 3 to remount that. Again, I may not have paid enough attention to keeping these sorted. I do believe these are going to be these 3 here. I know I need 3. These 3 are identical. They look like the ones that would be used. And we just start putting the screws in. I know you hear me harp on this a lot, and if you're watching, I am again turning the screw backwards till I feel it fall into the original thread. That just makes it very easy to turn in, not cutting new threads. It needs to come apart again. The plastic won't eventually wear out and the screws won't take a bite. So we know that that board mounted right there. We know that as a next step, this board set in here. Need to be careful not to crimp any cables up underneath. Break insulation. I mentioned in the teardown video the screws here were longer because they go through the metal body there. And I do believe that is this one and this one. Really hoping this will come back to life and work. And I'm not going to drive these in super tight until all the screws are started and I know everything's pretty much in alignment. We've now got 1, 2, 3, and 4. That we put in at this point, and that's 1, 2, should be these 4 right here. They're relatively short because they just go through the phenolic into the metal underneath. And then there's 2 slightly longer ones, which are these 2 that went here because they go through those ground straps. Hopefully the screwdriver will hold on to these magnetically so I can get them down in there easily. Because getting your fingers down in there would be difficult. I've actually already got the one in over there. There's 4 of these. There's one back in the center there. Why do I feel like I'm off by a screw here. Take a look at the punch outs. There's one over here, I do believe. No, there's no screw hole beneath that for a screw to go through, so there's not one there. It's just a support standoff. Sometimes these can be important in providing ground points as well. Either the circuit board presses up against the metal on the chassis. You typically wouldn't use that to bridge grounds between 2 points, though anything is of course possible. Now, this guy right here went to the forward location here, and then the one that comes in this way went to the back location for those. These, of course, wrapped up around to the board here, and luckily they're keyed, 2, 3, 4, 5 pins, so they really will only go on one way. Let's get the power in, connected. I'm a little bit confused here, and that this one and another one went to sheet metal. No, it's not there. It's not threaded. It must actually be, I'm not sure, this ground lead and another ground lead, if I remember visually here. Oh, I know what they went into. They go into the side here of this guy. Yeah, so he's on here, and there was 2 of these that came over to these 2 mounting points here with the lock washers. So there should be 2 more screws that hold this guy in place. Let me find a little box of screws and retrieve the screws for those. Although honestly that'll be easier to mount after I get things plugged in internally here. I'll hold off on him for now. Is there anything I'm missing here at this point? Or can I slide this back into the case and get the mounting screws in place? I think at this point that is our next logical step. Now we're back to a CRT with an exposed neck. And it becomes somewhat dangerous again. But I don't want to break the neck off that CRT, and I just came really close to tapping the shelf there with it. Don't know if you saw that or not. I'm glad I didn't. But I came very close, even paying attention and watching what I was doing. I nearly caught it there on that shelf. It's not as fragile as I'm maybe making it seem, but it is fragile. You are going to rotate up onto your side. There's a sea of cables in the way here. They all need to be pulled up out of the way. I don't want any of those getting trapped underneath. And you're really just going to slide up in here. seeing the screw holes appear. There it is. There's one. Two hands is, of course, never enough. Caught. This, of course, won't sit here on its own. It wants to rotate. There, that one has started. These need to be snug, not highly torqued. Now it's starting to look like a monitor again. This guy can be pushed out of the way. They are for the power switch. This one here is the guy that went in here. The two identical red and black ones I complained about earlier, and I've mentioned a couple times since. Fish all of these loose. Find the little container of screws. I can get it to open here. And there should be two that are this length. And one of them goes here. There's no screws caught up underneath them, or wires. I'm going to crimp accidentally. That picks up one of those grounds that's wrapped around front to that wire around the CRT. The other one's on this side. I don't know if I'm going to be able to do this completely from memory or not. I guess we will find out. You were in there. Just retouch the one on this side. Now I'm missing a wiring loom. Went there. This and this. There were two of these. The shorter one was on this ground lug here. The longer one came up to the board on the neck here. I'll put him in later because I'm not finding wiring harness that I thought went to there. There's a 4-pin harness that I am not finding. Yeah, I may have to go back and refer to the photos. You're on the neck of the CRT. This wraps around to that driver board on the side. Those are all hardwired, of course. CRT connection and yoke connection, and I'm not going to hook up yet, just to help keep the leads out of the way. I guess I can fish through. these two guys, the power switch connections. Trying to decide the best way to route these. Oh, these are not both power switch. This one's a degaussing coil. Interesting. Only the red ones are the power. Okay, I'm gonna have to look. CN1 on-off switch. I'm gonna have to look at a photo. I believe what I've got here is I thought both of these went to the power switch, but I can see here this one actually goes to the degaussing coil on the CRT, and this one's the switch. And I think these were in this way, the white in the back, but I'll have to look at a photo. I know that this connector here is speaker because it's an inline. That's really too short to come around to the sidecar board. I'm really surprised at all of these potentiometers here. It's got, okay, going off. Well, I'm gonna stop the camera here and look at some photos, and then I'll be back. Well, it took a bit of digging to find the wire harness that come up to there. It actually comes from the 3 little pots that we screwed in the back here. Is actually what those came up to. So I'm going to continue to hang hardware here. I don't see any open connections. I know this pot has been bumped here. Switch. Oh, it's actually a switch. Because in the photos it's over to the far left there. I assumed it was some kind of a pot, but it's actually a switch. Well, we will keep hooking cables into place. Get this guy back in place. I'm going to release the wire tie here, and I'm going to hang this back on the neck of the CRT. Just because it'll help pull some of the wiring up out of the way. There's a ground connection that goes on there. This is keyed. It only goes on the one way. Going to have to look at some more photos. To the best of my memory, the degaussing coil was on the back set, and the power switch was on the front set of posts there. Kind of move all the wiring out of the way here. I can rehang this board. Mounts all the way up into here. Using these 2 screws. didn't work. Not sure how much you can actually see what I'm doing here. It's kind of all hidden. Screwdriver keeps slipping out of the screw there. Caught. I have no wires being crimped. Screw there and a screw there. There's two grounds here that go. Looks like the green one will fit easiest down low. Into there. And into here. If I can get the screw to start. Being stressed. This is the lead that was labeled plus 12. It comes to here. This is what I'm believing to be the red, green, blue drive outputs. Up to here. Let's fish out the remaining connectors. See if we can sort out where they go. This is a 3-pin, probably right there. That's a 3-pin. I'll see those could be interchanged easily. I'm going to have to look at photos to find color coding for these. I want to kind of sort all the wires on top of the little bundle here. I'm pretty confident this guy back in here goes right there. It wouldn't reach anywhere else. And it is labeled, well, it's just labeled connection 401. So let me go off and reference the photos again, and we'll get the rest of this plugged up, and we'll see what happens. So at this point, we've got all the cables back in. There was a little one down here that took a second to sort out. Based on the photos, I've got all the colors correct here. I know this one down here is the actual RGB in from the video input cable. I don't need it hooked up at the moment. Got power coming in. Boards are all hooked up. Both of the ground references are plugged in. I don't see any loose wiring floating around. I have voltages hooked up. There's no loose wires. There's no open connectors. I'd like to start with the power switch open. Easiest way I know to check that is just to do an ohm check through the power cord. We saw about, I think, 31 ohms on the primary before. So if I'm seeing 31 ohms here, which I'm not, so the power switch is off. Power switch is on, 32 ohms. So the power switch is off. So I can start with it off. Since I've got the isolation transformer on the bench, I'm just going to go ahead and go through the isolation transformer. There's no reason not to. And I guess it's the moment of truth. We're either going to get a power LED light that comes on, and a monitor that tries to work, or we're going to get smoke and flames and God knows what. Here goes. Still don't have a power LED. Don't have a heater in the neck of the CRT, so we have, whatever has failed is still failing. Well, that's a shame. That's a lot of work to get to this point and not have anything. Yeah, there's no high voltage whine. There's just dead monitor. I don't believe this requires a video signal in to come on. Wouldn't that be a slap in the face if it did? Although we know we had at least 2 caps in really bad shape. There's no relay or anything in here that would indicate to me that it required a video signal to actually power up. Well, that's truly a shame. Does not particularly please me. Although it's kind of par for the course. So I'm going to do just a quick and dirty voltage measurement, volts DC. Get someplace on the chassis here. I'm going to assume this 12 volt isn't isolated. And just see if I measure anything on here. Of course, I expect not to see anything. Get them through the isolation transformer. No surprise, absolutely nothing. Looks like it's a a linear power supply, so I'm just kind of thinking here about what this could be without schematic and troubleshooting guide. I'm going to probably have to spring for that $5 manual I found online. And see if it has at least a expected voltages and that kind of stuff. Can't get this unplugged from the isolation transformer. Well, just out of desperation, I'm going to bypass the isolation transformer and just go directly into the power strip. Don't expect it to make any difference. And of course it doesn't. And of course with the board, being back in the metal bracket, it's basically impossible to get underneath and just do some basic probing around. There's a few things I can poke at. Line voltage. Line voltage. Line voltage. So the switched side of the switch, I can see switching. Gaussing coil is energized. Well, there's 58 volts sitting there across that resistor. Volts DC, I would expect that to be DC at that point, although maybe not. Volts AC. Yeah, there's 58 volts. Bridging the power supply side to the monitor side. You know, the fact that we don't have a power LED just continues to say power supply polymer. We're not seeing the 12 volts. We could have a winding open in the power transformer, which could have happened when that capacitor failed and shorted. At this point, I'm really going to have to look for a service manual. Well, that's disappointing. I had high hopes and got nowhere. So, well, I hope you learned something. Probably not, but I'll keep poking at it.